Okay, so this is the reteach for TEAC 8.5G functions. Your objective here, your learning objective is I can determine if a relationship represents a function. So remember, when we're looking at a function, in order for it to be a function, an x values can only be paired with one y value. So that's really important to understand, is that these only one x value with one y value. So what we can't have is repeating x values. That makes this not a function. So an ordered pair is written with an x, comma, y. So what we're looking at is that first number, and what we're looking for is there any repeating x values. So if we go look at these relationships with ordered pairs, looking at the first one, I'm going to highlight all the x values. And what I want to see is, do any repeat? In this case, we have a positive 5, positive 6, negative 5, and 0. Since none of these repeat, then we can say that this is a function. Let's look at the next example. So come over here and highlight, remember the x values are the first ones, and I'm looking for any repeating x values. In this case, I do see that 9 is repeating, positive 9, 6, 5, positive 9. I do need to check to make sure that it's a different y value. In this case, 9 is with 2, 9 is also with 3, therefore this is not a function because we have a repeating x value with a different y value. So let's look at the last one. So I see 6, negative 1, 8, negative 1. So I do see repeating x values here in negative 1. But we have to be careful because remember the definition is one x value with one y value. And if we look at the y value, negative 1 is with positive 3, negative 1 with this positive 3. That is still the same relationship. That's still the same ordered pair. It's just written twice. So because technically it's not a different y value, this still represents a function. Alright, so let's go take it to the next representation. So with tables, the definition doesn't change. We're still going to be looking at the x values. And then these are vertical tables. And on vertical tables, the x values are going to be the ones on the left. And so those are the ones that I'm going to be looking at. And I want to see, are there any repeating x values on the x column? In this case, I have a positive 1, 2, positive 1, 2. So I actually have two sets of repeating x values. And remember, we do have to check the y to make sure that they're different y values. And what we can see is that none of these y values match. So therefore, this is not a function because there is not a 1x to 1y. We have a repeating x value with different y's. As compared to the other table, where I have a 1, 3, 5, 7, negative 7, none of these x values repeat. Therefore, this is a function. If you were looking at a horizontal table, it would be the same thing. We're still looking at x values, but remember x values are on top, y values are on bottom. So mapping is the new version of data that you guys have seen this year as 8th grade students. And when we're looking at mapping, we need to remember that the x values are represented in the first circle, the y values are represented in the second one, or you can say x is on the left, y is on the right. The definition is still one x value can only be paired with one y value. And with the mapping, what we're looking for is one x, or the x values, only have one arrow. If the x values only have one arrow coming out of them, it is a function. Now remember, y values can have as many arrows as they want pointed at them, are lines. But what we're looking for are these x values only having one arrow or one line coming out of them. So like for example here, I see negative 35, negative 5, and 0 are my x values, but I also see that negative 35 has two arrows coming out of it. And because that's true, this makes this not a function. as compared to the other representation, where I look at these x values, I see -1, 0, 1, 2, and 8. And I notice that all of these x's only have one line or arrow coming out of them. That means that there are no repeating x values, therefore this is a function. So with this one, we're looking at these lines and these arrows and seeing that as long as one line for the x comes out of each of the numbers, then it is a function. All right, the last representation is the graphs. And again, you notice that the definition of a function doesn't change. Now the way we look at it is a little different. And you can see all sorts of types of graphs. You can see lines, you can see squares, circles, dots. And what we use to determine if it's a function or not is what we call the vertical line test. And remember, a vertical line is a line that goes straight up and down. And so basically what I want to know is, am I going to be able to connect two dots that are on the line with a vertical line? So for example, if I look at this first graph and I draw a straight line down from the dots, at any point will I touch two of these dots with this vertical line, any of these vertical lines. And because I cannot make a connection of two dots with a vertical line, none of these x values repeat, then this is an example of what a function looks like on a graph. So this is one example of how we can graph a function. As compared to the square. So if I look at the square and I put a dot for an ordered pair and a dot for an ordered pair, then I took a vertical line and I drew it, could I connect the two dots? And because I can connect two dots on one vertical line, this fails the vertical line test, therefore this is not a function. The same can be said of an actual vertical line graphed. I can actually put many points on this line that are connected. A vertical line on a graph is also not a function. Okay, so what you're going to do now is continue on to the next slide and go ahead and start answering some questions about functions not a function to make sure that you guys understand that. If you need help, please ask your teacher, and good luck.